Welcome to week 2, getting started with tools. So starting from this week, we're going to get our hands wet with different kind of tools to build visualizations. In particular, this week, we're going to look at Python and R. So again, this is our usual slide to acknowledge the source of the materials. Okay, so here's the agenda. We're going to review the readings we have from last week. We're going to take a quick look at the Python exercises. And then we will start talking about this question of how do you come up with compelling questions that your visualization should answer. And then we can briefly talk about the assignments for next week. Okay, telling stories with data. So this is from the chapter 1 of the book Visualize This. So how do we tell stories, right? So if you remember from last week's lecture, I said that, just visualization is not just about creating beautiful pictures. It is creating effective, compelling visualization that can tell stories, that can engage your audience, your readers. So how do you do that? Well, you should be able, your visualization should convey different patterns that's inherent in your data set. So there are three major types of patterns, right? So first, you have the exploratory, where you wanted to find questions, or explore questions that your visualization should answer. The second is you want to look at the change over time, right? Especially if you have time series data. And third, you want to look at aggregates, not just individual data points, but also aggregations. Now, a lot of times visualizations are created to highlight or uncover relationships in your data set. In statistics, there are correlations and causation, right? So correlations means that the two variables are correlated, whereas causation means one variable causes the other variable, right? And usually, you know that you can't be sure that there is causation unless you're doing any type of control experiments, right? You control for something, and then you're confident that the results you saw was caused by the thing that you manipulate. And oftentimes our datasets have a number of variables, and we would like to explore the relationships between these variables. And again, visualization is a powerful tool for you to explore or uncover these relationships among different variables. The third thing we need to pay attention to is encodings. By encodings, I mean the mapping of your variables in your dataset to the geometric components or the visual components. For example, whether you use circles, bars, or colors to represent data points. You also need labels, legends, and keys for your readers to understand what do you mean by these graphical elements. And last but not least, context is also very important. You should make sure that the visualization that you created should convey the context in which the data set or the data is going to represent. All right, so once you have an idea of the kinds of data question you want to ask, next you need to get your hands dirty with the data. Well, where do data come from? Well, according to the book, there's always the internet. There are governments and universities. But we also know there are data come from companies, right? How do you get the data? Well, in the ideal case, you can simply, somebody else has already done the hard work. They have, created and cleaned the data, and then you can just go ahead and download it. That would be the easiest case. Well, sometimes it's not as easy as that. You might have to collect your own data, for example, by scraping the web, right? Scraping certain websites, web pages, and then you get prepared for your data set. And sometimes you have to collect data, for example, through APIs. Let's say you wanted to crawl, Facebook users' behavior data on Facebook. You might be able to, to get that data, collect that data through the Facebook APIs. But of course, these service providers will impose various requirements or limitations. So let's assume that now somehow you get the data. All right, then what do you do with it? Well, before you can do anything with it, you still need to understand the limits, the limitation of the data. Well, first of all, you need to know where did the data come from, right? Identifying the sources of the data set. And then you need to verify the quality, or at least be aware of the quality or the accuracy of your data. Whether the data is very noisy or it has been cleaned already. And then you need to format your data in a way that your analysis code can go ahead and analyze it, right? So once you format the data in a way that's analyzable, and then you can actually start with analyzing your data by exploratory analysis, which this famous statistician John Tukey advocated. Okay, so again, visualizations are not just beautiful pictures. They are effective graphical representation of the data set that tells a good story, an engaging story. And supposedly you should uncover insights that is not readily perceivable from just eyeballing the data set itself. So here's a very nice example, right? So the way we read this graph, right, x-axis you have the year, so it seems like this is a time series data. On the y-axis on the left, you have the sales of organic food, right, in $1 million. And on the right-hand side, y-axis, you have the number of individuals that are diagnosed with autism. And this is really compelling because now the question is, these two curves seems to almost overlap. I mean, they exhibit a very close similarity, right? The number of individuals diagnosed with autism on the top, and on the bottom you have the sales data for organic food. And you see that there's this little r, which is 0.997, which is the correlation, and it's very significant, less than 0.0001. So, which means that these two variables are highly correlated. What does it mean? Right, which is the as the title suggests, or asks, the real cause of increasing autism prevalence. Right. The question is, hey, is organic food the reason that causes increase of autism? Well, again, this is a very interesting graph. It's very thought-provoking. Of course, we don't know for sure that's the case because, again, don't forget, this is correlation. This is not causation. But, this is still, it conveys the purpose of this graph. It makes people to think about, what is the impact of organic food? Well, let's rethink about that. Speaking of compelling visualization, Hans Rosling gave one of the most compelling story of having compelling visualizations, and I highly recommend you to watch this video if you haven't, which is quite short, less than 5 minutes. And as another example, maps are classical and age-old visualizations, right? And here you have 40 maps that really help you think about the world that we live in. And I again ask you and urge you to take a look at this article and look at all these beautiful and thought-provoking maps of the